All right, so in this video, I'm going to factor these cubic equations using factor theorem and synthetic division. So for factor theorem, what you want to do is you want to sub in values of x that are multiples of this number, and you want to get 0 in this equation. So I always start with the lowest multiple of 60, which is 1. 1 is the lowest multiple of everything else. So I'm going to find f of 1 by subbing in x as 1 in my calculator for this equation. And you want to try all positive and negative multiples. So 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. When I do f of 1, I get negative 42. This is not equal to 0. So 1 is not a factor of this equation. So if 1 doesn't work, I'll try 2. And let's see if I get a solution that's 0 or closer to 0. If I substitute 2 into this equation, I get 0. This means x minus 2 is a factor of this equation. So next, I'm going to do synthetic division. I'm going to put this this 2 over here. I'm going to put all the coefficients of my terms over here. So for x cubed, it's 1. X squared, it's 9. For x, it's 8. And then a negative 60 is the constant. So now the first thing I'll do is I will bring this number down. Then I'll multiply these two numbers to get the next number here. So 2 times 1 is 2. Then I'll add these two numbers. 9 plus 2 is 11. Then I'll multiply these two to get the next number here. That's 22. Add these two to get 30. Multiply these two, get 60. Final solution here should be 0 because this is your remainder. We've already proven with factor theorem that our remainder is 0, so you have to get 0 at the end. So now if I write this equation in partially factored form, my first factor from the 2 is going to be x minus 2 because the solution of x minus 2 is basically positive. 2, these are the coefficients of the equation 1 degree smaller than this. So this is x cubed, which means this is going to be an x square equation. So this is going to be x squared plus 11x plus 30. Then we can simply do our man method over here. So what multiplies to 30 and adds to 11? This is just a simple trinomial factoring. 6 and 5. Basically grade 10 math, so hopefully you know how to factor simple trinomials. So my solution here is x minus 2 times x plus 6 plus x plus 5, and that's in fully factored form. Let's take a look at the second question over here. This one is slightly harder, and then the third one is going to be the hardest, but I'm going to explain all three of them in a lot of detail. Let's start with this one over here. What we notice when we look at the question is the x squared term is missing. I want to take multiples of the last number. So I can take 1, 2, 3, or negative 1, negative 2, negative 3. I always just go in order unless I can tell the solution mentally. So I'm going to start with f of 1. If I sub in 1 into this equation, 1 to the power of 3 minus 7 times 1 minus 6 is negative 12. So 1 does not work. Let me try positive 2, see if that works. Get negative 12 for 2 as well. This is a bit strange. I've never seen the same answer, but positive numbers don't seem to be working. So I'll try negative 1 and negative 2 and see how that goes. So if I put in negative 1 over here, my calculator, I will get 0. I know that x plus 1 is going to be a factor of this equation over here. Now, when I set up my synthetic division, I'm putting this number, which equals to 0, on the outside, and I'm putting my coefficients of my main equation inside, but make sure to note that x squared is missing. So my first coefficient for x cubed is 1. For x squared, it's 0. Then -7 for x, -6. So make sure you include any missing terms as well with the coefficients. These have to be in order. Going to bring the 1 down, multiply these two terms over here, add these two, multiply these two, add these two, multiply these two, and get my remainder as 0, so I know all my steps are correct. So if I write this down, that's going to be x plus 1, because the solution to x plus 1 is -1. This is going to be x squared minus x minus 6. Then I'm just factoring this as a simple trinomial with my man method. So m is -6, a is -1, which means my numbers are -3 and 2. Final solution, x plus 1, x minus 3, x plus 2. Let's take a look at this third question here. Now, this third question can actually be done in two ways. You can do factor theorem and synthetic division. There's also a much quicker way, which I'll show at the end. So I would strongly suggest, after looking at the steps for this, look at the second way I solved this. It's going to be much quicker. It's going to save you a lot of time on your test. So I'm going to find my first factor that multiplies into this. So I'm going to take multiples of 4. I'll start with +1 and +2 and see if those work. So f of 1 is 0. So I already got my first factor. So now when I'm setting up my synthetic division, I'm going to put this 1 on the outside. My coefficient of x4 is 1. My x cubed term is missing, so I'm going to put a 0. My x squared term is -5. My x term is missing, so I'm going to put another 0. And my constant is 4. Then I'll do synthetic divisions. I'm going to bring the 1 down. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -5 times 1 is -4. 1 times -4 is -4. 0 plus -4 is -4. 1 times -4 is -4, and I get 0 at the end. So I can rewrite this as f of x equals x minus 1, which is that equation there. And then x to the power 4 equation is going to turn cubic. This is a cubic equation down here. So x cubed plus x squared minus 4x minus 4. Then I need to factor this over here. Again, I'm going to do synthetic division. So I'm going to try 2 in this equation. Let's see if 2 works. So f of 2, I'm only going to sub it in this in my calculator, not in the whole equation. And if I sub it in that, you could honestly sub in the whole equation as well. Both will give you same answer. I do get 0 over here. So I know that f of 2 works for this one. So now I'm going to set up my synthetic division for this cubic equation here. 2, 1, 1, -4, -4. Bring down the 1. 2 times 1 is 2. That's 3. 3 times 2 is 6. That's 2. 2 times 2 is 4. And I get 0. So now I can rewrite this as f of x equals x minus 1. Then this is x minus 2. And then I have x squared plus 3x plus 2. And I can factor this with my man method. Multiplies to 2, adds to 3. My two numbers are just 1 and 2. So my final solution is x minus 1, x minus 2, x plus 1, x plus 2. Now, you saw how long this problem took. I had to do synthetic division twice and factoring. I'm going to show you a really quick way to do this now. I'm going to rewrite the question here. So f of x equals x4 minus 5x squared plus 4. And if you can identify that this equation is just a simple trinomial with a higher degree, I can literally do my man method over here. What multiplies to 4 and adds to 5, that's -4 and -1. So when I'm writing this in factored form, f of x equals x squared minus 4 times x squared minus 1, and then I can difference of squares these two. This is just x plus 2 times x minus 2. And this is just x plus 1 times x minus 1. What you notice is these two solutions are identical. Order might be slightly different, but they are the exact same. And over here, you see I just did this in 3 steps, super quick, under a minute. Whereas this one, it takes quite a bit. You have to do synthetic division twice and a lot of calculations. So if you can recognize these, you can do these quicker without synthetic division, but there are very few questions like this. I just thought it was an interesting question, so I would discuss it both ways in this video.